This is practice A for section 6.5. We're going to look at numbers 24 and 25. Number 24 is about stadium seats. Your seat at a football game is directly in front of the 10-yard line. So that's where you're going to be, directly in front of the 10-yard line. It's 30 yards from the field. So this measurement from where you are to that 10-yard line is 30 yards. Your position forms congruent angles with the 10-yard line, the 25-yard line, and the 50-yard line. So notice how that gives you congruent angles there. So you have this triangle that has two triangles inside of it, this ray splitting this one angle into two congruent pieces. That's theorem 6.7. So I'll write that on here. So if you're not sure how to solve this, go back up to your other examples where you use theorem 6.7. It's the same diagram, just different numbers. How far are you from where the 50-yard line intersects the sideline? Okay, so we're looking for this distance right here. So maybe I'll call that x. Now, this is the thing maybe you're missing. If that's the 10-yard line and that's the 25-yard line, isn't this length 15 yards? And if that's the 25 and that's the 50, isn't this 25 yards? Don't lose sight of that. Now, this is your proportion. 30 to 15 is the same thing as x to 25. $30 to 15. 15 times 2 gives you 30. 25 times 2 gives you 50. Number 25, this is about house design. The figure is a diagram of a cross-section of the attic of a house. A vent pipe comes through the floor 6 feet from the edge of the house. What's the distance x on the roof from the edge of the roof to the vent pipe? So you've seen lots of examples like this. Now, the only thing that this is maybe leaving out, oh no it isn't, these are both right angles. You need these to be parallel, and they definitely are because of these right angles. These are corresponding angles, they're the same, so the lines are parallel. Now, you've seen this example a lot as well. Here, here. This is theorem 6.4. Now, if you're going to use theorem 6.4, you need to be really careful, because this side gets split into a 6 and a 9, and this side gets split into an x and a nothing there. So if you're going to do the 6 to 9 thing, that's fine, and you can compare it with x to whatever this is. Just make sure you're not putting 18 for there, because this length is definitely not 18. Okay, let me go through and show you another way, then we'll come back and talk about this one again. 6 is the entire bottom of the small triangle. Let's compare that with the entire bottom of that medium-sized triangle. 15. 6 plus 9 is 15. So that's this whole thing. And the reason I use that 15 is I know that this 18 corresponds with that 15. Right? So x to 18 is the same thing as 6 to 15. That's one way to do it. If you didn't know any of these shortcut theorems from this section, this is how you would do that. This one over here now, we've done this before, I think, in the lesson. If this whole thing is 18 and that's x, this is 18 minus whatever x is. Either way you solve, you're going to get the same answer. Okay? So I'll solve it this way. Chances are if you did this on your own, you probably didn't set it up this way. You probably did it incorrectly. You probably put x over 18. So 9 times x is 9x. 6 times the quantity, 18 minus x, will solve that. Got to distribute there. So 6 times 18 gives you, I think, 108. Sounds right. Minus 6x. Okay, we're going to add 6x to both sides. So we're going to get 15x equals 108. and then we're going to divide by 15. So what is 108 divided by 15? Gives you 7.2. Now, what happens over here? Well, I guess I can show you my calculator. We're going to do 6 times 18 and then divide by 15. Does that look familiar? Yeah, it's the same thing we just did. It's 7.2.